All right, welcome back, Hononegah, Algebra 1. We're going to do section 5.2 today. We're going to start off with a little bit of an exploration. Usually we kind of do this as a partner activity, but you guys can just follow along with me. So I'm going to graph the top line. So I'm going to solve it. So I'm going to subtract 2x. I'm going to divide by 2 so that I can get the slope and the y-intercept. So the slope is -1, and the y-intercept is the point 0, 2. So 0, 2 with a slope of -1. And again, like we did in section 5.1, I'm going to put a few more points than what I might normally put because, again, I'm going to graph a second one and I want to know where it intersects at. So anytime you do a system in graphing, you probably want to put a few extra points. The next one, again, I'm going to solve it for y. And this is a little bit harder, but you end up with positive a half x plus 0. So 0 with an up 1 over 2. Well, wait a minute. This didn't happen in section 5.1. When I go to graph this, it doesn't cross exactly at a point. So does it cross at a point where there's integers? The answer to that question is no, it doesn't. And so if it's no, then we can estimate. Like we can come close. Like it looks like it's crossing a little above 1. And so if I actually wanted to, it actually is crossing at like 1.3. And so when you plug in one, basically when you're looking at that, and it looks like it also then crosses at 0.75 or something like that. So again, that's an estimation as to where they're crossing at. That's not exactly where they're crossing. So there's got to be some better methods. Like there's got to be something like, well, it looks like it's this. It's not good enough. And so what the method we're going to learn today is called substitution. So anytime you are trying to solve algebraically, not by graphing, then substitution is one of the methods that we can do. So there's some steps involved with substitution. And I'm going to walk you through this. The first thing I have to do is take one of the equation and solve it for x or y. Doesn't matter which one, but I need an x equals or a y equals in one of the equations. Now, I will tell you this, when you're trying to decide which one to pick, always pick the one that's the easiest. And the one that's the easiest is the one that has a coefficient of 1, meaning it's an x by itself, or there's a y by itself. But the first step is to solve one of the equations for x or y. Then substitute into the other equation, or replace the letter in the other equation with the equation from the new one. Then take the new equation and solve it. And then go back and find the other variable, and then always write your answer as an ordered pair. Okay, so you'll write it with basically the answer for x and the answer for y. So let's go through a problem here. First thing I want to do is solve for x, or solve for y. Notice that the bottom equation, okay, the bottom equation, I could solve this easily for x. So I can add 2y. And so I'm in place of the x in the other equation, I am now going to put 2y. So in place of the x, so notice this 2y is going in place of that x. Now, solve like you would normally solve. And so y is equal to 2/3. And then if I go back over here, and in place of y, I put 2/3. And so the answer to the exploration question that we did in the very beginning was technically 4/3, 2/3. So notice that it did not actually cross at an integer point like we thought. It's crossing at a decimal or a fractional intersection. So that's a little bit complicated. So let's do a little bit easier examples here. The top equation is solved for x. So x equals 6 minus 4y. So in substitution, in place of the x, so I'm rewriting the bottom equation, and instead of writing an x, I am now putting 6 minus 4y. So I am replacing the x because that's what x equals. X equals 6 minus 4y. Now, forget about everything else. Just solve the equation. So distribute. So if I gave you this question back in chapter 1, you would add like terms. Then you would subtract 12 and divide by negative 11. So y is equal to 1. That's half your answer. I now go all the way back to the beginning, and instead of a y, I'm now going to put a 1. So x equals 6 minus 4 times 1. So 6 minus 4 is 2. So the answer to this question is 2 for x and 1 for y. Next one. Okay, we're going to start from the beginning again. One of the equations needs to be either x equals or y equals. In this case, we have a y equals in the bottom. So now take the top equation, and instead of a y, replace it with a negative 2x minus 2. So notice this y is gone, and I replaced it with the other equation. Now, don't look at anything else, just solve the equation in front of you. So I'm going to distribute the 3. I'm going to add like terms. I'm going to add 6 and get x to be negative 3. I'm not done. That's just half your answer. I now am going to go back up into the original questions, and instead of this x, I'm going to write negative 3. So y would equal negative 2 times negative 3 minus 2. So I end up getting y equals 4. So writing this as a point, x, y, x would be negative 3, and y would be 4. Now, notice neither one of the equations has been solved for the letter. Like the letter is not by itself. So anytime you're going to try to solve by substitution and you do not have an equation in which it is solved for a letter, you need to solve for either x or y. I'm going to take the bottom equation here and solve it for y. So I took the bottom equation and solved it for y. Now I'm going to take the top equation, and instead of writing a y, I'm going to give myself some more space, but instead of writing a y, I'm going to write negative x plus 31. So I took one of the equations and solved it for a letter, and then replaced that in the other equation. Solve it like you would normally solve it. Don't look at anything else, but just solve this equation, your new equation you want to try to solve. So add like terms. Subtract 62, negative 68, divide by negative 17, x would equal 4. Now I take that, remember that's half your answer. I'm going to put 4 now instead of the x and find out what y would equal. So negative 8 times 4 is negative 32 plus 31. So the answer to this question is 4 for x and negative 1 for y. Notice on the next one, again, we're going to try to solve this by substitution, but none of the equations has been solved for a letter. The easiest one in this case is the x on top, because it only has a negative sign in front. So if I subtracted 3y, I'd have negative x equals negative 3y minus 9. And if I divided everything through by negative 1, the top equation is now solved for x. So take the bottom equation, and instead of writing an x, you put 3y plus 9. Now, forget about everything else, just solve your new equation. So if I solve the new equation, I would distribute. So 8 times 3 is 24. Y plus 72. Add the like terms together. So 24y minus 4y. Subtract 72, which is negative 40, and divide by 20. I get y to be negative 2. I'm now going to go way back up in the top, and instead of the y, I'm going to put a negative 2. So 3 times negative 2 is negative 6, and negative 6 plus 9 is positive 3. So positive x equals positive 3. So positive 3, negative 2 is the answer for x and y. Now I get to more real world questions. And if you remember right in section 5.1, we tried to solve one of these by graphing. And that's a little more challenging. But to solve one of these with substitution or elimination can be done. The drama club earns $10.40 from a production. The total number of adult tickets was 64. So 64 adults and 132 students for 1,040. The adult tickets cost twice as much as the student tickets. So if I take the student tickets, excuse me, if I double the student tickets, it would equal the adult tickets. Now, with that being said, I now have two equations that I can try to solve, and x equals 2y. So in place of the top equation, I'm going to write 2y instead of x. So 64, 2y, plus 132y equals 1040. So this is 128y. So multiplying, I'm solving just this equation. So I add those together, I get 260. So 128 plus 132 is 260. And divide by 260. So pull out a calculator if you need to. So 1040 divided by 260 would be 4. So now if I go back, this is just the y answer. If I go back and instead of the y, I put a 4, then x is 8. And so what does that mean? The price of the adult tickets, so $8 for adults, and $4 for students. We're going to do a lot more word problems as this chapter goes along, but ultimately solving a system by substitution. You try this next one, or you try the next two, sorry, all by yourself. So hit pause. All right, welcome back. Let's see if you get it right. So y equals 4x plus 14. So instead of the y in the top equation, I am going to substitute or replace the y with a 4x plus 14. Now, solve this just like you would in chapter 1. You would distribute. You would add the like terms together. You would then subtract 42 and divide each side by 15. So I'd get negative 4. Now go all the way back in the beginning, and instead of the x, you're going to put a negative 4. So negative 16 plus 14 is negative 2. So writing my answer as a point, an ordered pair, so negative 4 for x and negative 2 for y. Now for the word problem. There's a total of 64 students in the drama club. The drama club has 10 more students than the yearbook club. Write the system. So the amount of people in the drama club plus the amount of people in the yearbook club adds up to 64 total people. The drama club has 10 more students than the yearbooks. So yearbook would equal drama plus 10. Now I have a system. Y is equal to x plus 10. I can replace y in the top equation with x plus 10. Nothing to distribute this time. So x plus x would be 2x. Subtract 10 and divide by 2. So x is equal to 27. Go back over here, and instead of the y, you put a 27. So y would equal 37. So what does that mean? There's 27 kids in the drama club, and there's 37 students or students, yes, in the yearbook. Your homework assignment tonight is in page 245, 19 through 16 all, 19, 20, 25, 36 through 41 all. If you have any questions, please make sure you talk to your teacher. This is a challenging one, So please make sure that you do your best. And if you have problems, make sure you ask, and good luck.